Okay, we're in section 45. This is I would say a difficult section. All right, so we're going to break the examples into two parts because I don't think I'll be able to finish it in a reasonable amount of time. Again, the structure of the document, there'll be contents. You're to read through the contents. You try to understand the examples as presented. Again, for the students that don't need walkthroughs, you don't need to watch these walkthroughs. The intent here is after you do the contents and examples is to start the exercises. My name is Ron Bannon. This is the draft version of my adaptation of Webster Wells' Advanced Course in Algebra, which dates back to 1904. This document is being prepared for the prison mathematics project participants only. At some point in the future, it will be published. I realize these things are on YouTube, and many people have access to these things beyond the prison mathematics project participants. And if you're interested, you can contact me and let me know that you're interested in receiving a copy of this, and I'll let you know when it's going to be published. All right? I'll certainly publish the PDF, and I'll also probably publish the LaTeX version for teachers and students that want to adapt the work for their own purposes. So let's take a look. This is all about surds. Again, hopefully you're reading the document. You have a good idea what a surd is now and what they want you to do with the surds. All right? So I'm gonna divide the problem set, the examples, and you can see this is a rather lengthy section over here. I'm going to divide the examples, sorry about that, into two parts. All right, so as I'm doing this over here, I want to claim that a lot of modern students now would look at this problem and say they wouldn't even know where to start with it. But it's really a basic problem. So what I want to do is I want to write down, this is really just 8 to the 1/6 power. Now there's not 6 equal factors of 8, so I'm going to say there's probably some work to do over here. What I want to do is simply say it's really 2 cubed. That's what 8 is, and that's to the 1/6 power. And we're trying to simplify this into a simpler statement. I can use rules of exponent, and 3 times 1/6 is a half. Again, I want to point out the spoken roots, we're going to answer in a root, and the root would be the root of 2. So the 6th root of 8 is equivalent to the root of 2. That's done. Easy peasy, lemon squeezy. Let's do this one over here. This is a cube root of 54. I'll write that down for you. Again, 3 equal factors of 54 not going to happen, but what I'm going to say is, I wonder if there are 3 factors in 54 that I could deal with. And certainly there are, and I'll point out what they are. It would be 27. Now someone says, why did you choose 27? Because 27 times 2 is 54, and 27 contains 3 equal factors. And what are those 3 equal factors going to be? 3 cubed. That would be 27 times 2. What's cube root of 3 cubed? 3. Then you get the cube root of 2. This is considered simplification. All right, that's done. Let's do the next one. And again, I'm looking at it, and certainly what I would do first is I know they want a square root of it, and I'm looking for factors now. And so if I'm going to do that, I want to write this down for you. I'm looking at the radicand. I'm going to factor the radicand first. So I'm going to say I see a 3 common to all 3 of those terms. I see an A common to all 3 of those terms, and I see a B common to all 3 of those terms. What are you left off with? Well, let's write it down. Be careful about it. You'd be left with what? A squared. Let's see, minus 4. You need an AB now. And then plus, looks like 4, and you would need a B squared. And we're going to be taking the square root of that if we can. But again, I'm looking around for, some squares. So let's take a look. And, 3 is not a perfect square. A is not a perfect square. And B is not a perfect square. But what I notice this A squared minus 4AB is actually A minus 2B quantity squared. Now, this is where Wells and I kind of disagree what you should do over here. But Wells is making the assumption that A minus 2B is a positive. Right? And if you are making that assumption, his answer is fine. But, I should say non-zero, but if it were negative, if A minus B were a negative, you'd have a problem. So this is why I like to write the answer down this way over here. But again, this goes beyond Wells' scope. Wells' answer would be this over here. My answer would be this one, and it takes care of both cases. If A minus 2B is greater than or equal to 0, or if A minus 2B is less than 0, all right? I know this confuses students, but the bottom line here, the square root of x squared is not x, it's the absolute value of x. And this is going to require some thinking on your part. It requires some thinking. We got number 4, and it's a cube root problem. And I'm saying it, 1944, a terrible looking number, but I'll go through what I'd like you to do with it. And 1944, I'm going to try to break it into prime factors. Certainly I'm going to say 2. Right now, certainly if you're looking at 2 and you don't know how to do that, I'll write down it's a long division problem for some students. Let's see, that would be 9, 18. I'll erase this later. That's 18. 1, 4, 7, and 4, 2. So 9, 7, 2. Let me get my eraser out. That's my baby arithmetic. Again, if you don't need to do baby arithmetic, don't do it. And then I'm looking at 972, and I'm going to say 2 again. And I'll erase my baby arithmetic later. Well, 4, that would be 8. 17, 8, that would be 16. 1, 2, 6. 486. So 2, 4, 8, 6. Let me get my eraser, erase my baby arithmetic. And I don't know, 486, I don't think I need baby arithmetic on that one. So I'm just going to say something. It's 2. Let's see, 46 would be 243, right? Well, no longer a 2 now. But I'm looking at the 243, and I'm wondering what's the next prime up from 2 would be 3. Now, is that number divisible by 3? If the sum of the digits are divisible by 3, the numbers are by 3. Well, what's 2 plus 4 is 6? 6 plus 3 is 9. So now I'm convinced this number is divisible by 3. So 243, right? And again, it's not a bad number. So it's going to be 8, which is 24. G's 3, you get 81. I'll put this over here. So 3 times 81. Then I'm going to break the 81. That would be 3 times 27, and then 3 times 3. All right, so I'm going to write this down as the cube root, and I'll be very careful. I see 1, 2, 3 2s. I'll put this over here, 2 cubed. Now, I realize some students may argue they don't need to write that down. I'm not saying you do. I'm going to look for the 3's now. And how many 3's do I got? Oh, I'm sorry. I made a mistake. I just noticed it. That's not 3 times 3. It's 3 times 9. This would be 3 times 3. How many 3's do I got? Let's count them up. 1, 2, 3. I'll write that down. And we left off with 2 3's. 3 squared. Now, someone says, why are you putting them in groups of 3? It's a cube root problem. The cube root of 2 cubed is 2. The cube root of 3 cubed is 3. And the cube root of 9 now, I can't do that. So what are you going to get? 6 cube root of 9. That's done. Let's do the next one. They want simplest form. And for me to do this square root problem, I'm kind of looking for factorizations. Now, the 147 may cause some problems, but the 125 shouldn't. I certainly know the perfect square there. I'll write this down for you. And that's going to be 25. I like to put the perfect squares in front and the non-perfect squares, towards the back of the problem. And what times 25 will give you 25, 5. I'm going to look at the 147. And looking at it, that my rules of divisibility, if I added those 3 digits together, certainly it's not 2, by the way, but 3 works because the sum of the digits actually is divisible by 3. 1 plus 4 is 5, and 5 plus 7 is 12. And that's certainly divisible by 3. So I know it's divisible by 3. What are you going to get over here? 4. And, 4 times, let me get rid of this thing over here. 4 times 3 is 12. Then you get 27. And then what do you get? Well, 3 times what would be 27? 9. So 49 is also a perfect square. But times what? Times 3. The square root of 25 is 5. The square root of 49 is 7. You should recognize small perfect squares. And 3 times 5 is 15. So what do you get over here? 35 square root, or root of 15. Mistakes happen. That's why we'd like to give you an answer key to look at it. And there is work down here for you. Now, a little more difficult. A lot of variation in how to do the problem. But I want to just, emphasize to you again, there's some problems over here. One of the problems is I can't have a fraction as a radicand. That's one problem. I can't have any perfect square factors, and they're all over the place. 9's a perfect square, a contains a 4, and a cubed contains a square. But what I like to do is I like to, maybe simplify the fraction first to get it to look like a better perfect square for me, all right? So I'm going to write this over here. Whoops. And get my palette back. Yeah, I think I did it right. Let me get rid of that. So I'm going to write down square root 9 over 8a cubed. And what I'm going to do, I'm going to make the bottom a perfect square. And I just like to do that. But what times 8? It also makes it simpler for me to finish the problem. What times 8 would give you a perfect square? It would be 2. Now, what times a cubed would make it a perfect square? Well, a4 is a perfect square, so I'm going to say a. Now, what do you get? On top, you get this. You get 9 times 2a. We'll do that later. What do you get on bottom? The square root of 16a4. I want to remind you, I got rid of the fraction, and I just want to remind you, I cannot have a radical in the bottom. And that's the whole reason I did that. There isn't a radical in the bottom now. What's going to be 4a squared? What do you get on top? 3, because the square root of 9 is 3, and then the root of 2a. Done. Whoops, that's a 2. Make sure you look at that. Let me get my eraser out. All right, we did okay. Let's do the next one. Now, this one says they want you to reduce the surds to the same degree. And someone says, what do they mean degree? They actually mean the index. This is the index. So what I need to do is I need to get the LCM, the least common multiple, between 2, that's the square root, a 3, and a 4. What would that be? Well, let's take a look. That would be a 12, right? Let's write this down. 2 to the 1/2, 3 to the 1/3, and 5 to the 1/4. I'm going to write those fractions down, 1/2, 1/3, and 1/4 in terms of twelfths. What do you get? Well, let's see. That would be 6 twelfths, right? We'll take care of that later. What's next one going to be? 3, that would be 4 twelfths. What's next one going to be? 5 to the 3 twelfths. So these are all 12th roots. I'll write that down for you. So the square root of 2 is the same thing as the 12th root of 2 to the 6th power. I'll simplify that later. The cube root of 3 is the same thing as the 12th root of 3 to the 4th power. The 4th root of 5, there's a point to doing this, by the way. The 4th root of 5 is going to be the 12th root of 5 cubed. I want to write these down. As I do it, it's going to be the 12th root. I can do 2 to the 6. 2 times 2 is 4, times 2 is 8, 16, 32, 64. That's pretty easy to do. 3 to the 4th is 3 times 3 is 9, times 3 is 27, times 3 is 81. And this one over here would be the 12th root of 5 cubed. That's 5 times 5, which is 25, times 5 is 125. So I got this over here. I've written all those roots in the same index, which is the 12th root. Those answers are listed over there. Someone says, what's the point of that? I can now compare these numbers much more quickly, knowing that this guy here is the biggest, and this one's the smallest, and this guy's in between. Right? It's much easier to do that than looking at the original problems. All right, this one says the required sum. I want to point what that means. It means the square root of 20 plus the square root of 45. I need to simplify these radicals. When I say radicals, they're square roots. And the square root of 20, I want to point out, is really 4 times 5. And the square root of 45, I'm looking for a perfect square, is 9 times 5. So what does this give me? 2 root 5s plus 3 root 5s. Well, how many root 5s do you have? 2 and 3, which is 5. There's 5 root 5s. We're done with that. Let's keep going. And this one over here, again, I want to simplify it. And I'll kind of write it down. And I'm going to write this as, I'm going to try to get this in a proper form. I'm going to multiply, the 1/2 by something that makes the bottom a perfect square. And it's going to be the number 1, by the way, but I'll put 2 over 2 because that makes the bottom a perfect square. Let me go to the next one. And again, you may do something different. And again, you really need to work the problems the way you're comfortable doing them. And that's what I'm doing over here. 3 over 3. And then you get this over here. Be very careful about this. This would be 9 over 8. And I'm going to say 2 over 2. All right? Let's do this. What do you get? Root 2. Well, 2 times 2 is 4, and the square root of 4 is 2. Plus, this would be root 6, because 2 times 3 is 6. And the 3 times 3 is 9, and the root of 9 is 3. Minus, be very careful over here. This is going to be 3, because square root of 9 is 3, root 2. And at bottom you get 16. The square root of 16 is 4. All right, I got to get a common denominator. And the common denominator here is really not bad. It's just a 12. And let's start writing it down. Well, it's going to be 6 root 2's. Let's see, plus 4 root 6. And then what do you get in the end? You get minus 9 root 2's. Now, I'm not beyond making a mistake. And what I mean by that is I want to be very careful when I write an answer down to check it. And what do I see? I see 4 root 6. Let's see, minus 3 root 2's. This is a fine answer. That's the answer I would write down. But I realize a lot of times what happens is, students may see a different answer written down. Let me go through that with you. We'll check the key later. I'm splitting into two fractions. What do you get over here? Root 6 over 3 minus, what would that give you? Root of 2 over 4. I'm also going to say it's a good answer. Now, I'm not saying I didn't make an error, but let's look. And let's see if I got this one here. I'm seeing that. I did okay there. And then I get this one. And I'm seeing that. And you should see alternative answers. All right, this one says multiply. Well, that's pretty simple. They're both square roots. So root 6 times root 15. Well, I'm just going to multiply the radicands together. And 6 times 15 is 60 and 30, which is 90. What do I immediately notice here? I notice there's a 9 there. So the square root of 9 and the square root of 10. What's square root of 9? It's 3. And then you get root 10. Not much I can do about that. That's done. Let's do the next one. This one's a little bit more complicated. And the reason they have different indexes, one's a 2, one's a 3. So my first goal over here is to write them so they have the same index. This is 1/2 times 4a squared to the 1/3. Let me see if I can do that. Well, between 2 and 3 would be a 6, right? I'll write this over here for you. 2a. And I got to get a 6, so it's going to be 3/6. I'll take care of that later. And this one's going to be 4a squared to the 2/6. And I want to write them in terms of 6's now. So what I'm going to do, well, it's a whole number, 3, right? I want to point out that's a 3. So I'm going to cube the 2a. That would be 8a cubed to the 1/6. I'm just using simple rules of exponents. And here I'm going to square the argument. Again, the whole number is 2. What do you get over there? 16a4 to the 1/6. So what do I say? Let me go over here. It's going to be, 8a cubed times 16a4 to the 1/6 power. What does this give me? And I'll write down for you. It's 64. I know it's a lot of work. And then what do you get? You get a7, right? 1/6. So I still have to go for it. Someone says, what are you doing over here? I'm trying to find a perfect 6th. Let's take a look at that. And 64 has something to do with a 2. So I'm going to say 2 times 2 is 4, 8, 16, 32, 64. I think I made a mistake somewhere. I'm sorry, 8 times 16 is not 64. I just noticed that. And I got to correct it. We'll look at the answer later. Sorry about that. I had 64 in my brain, by the way. It's 128. Again, 8 times 16 is 80. And 8 times 6 is 48. 80 and 48 is 128. And what do I notice about this over here? Well, as I was saying before, powers of 2. And 2 to the 6 is 64. So it's going to be, let's put this down. 2 to the 6 times 2. A to the 6 times a. That's 1/6 power. What do you get over there? Well, the 6th root of 2 to the 6 is just going to be a 2. This one's taken care of. And this one would be taken over there. Just a. And we left off with the 6th root of 2a. All right, that's done. Let's do this one over here. Again, you might be looking and saying, what do you want to do over here? They want you to multiply. So it's going to be 5 to the 1/2 times 5 to the 1/6. I'm going to get the same index, and that's going to be 6. So 5 to the 3/6 times 5 to the 1/6. Again, a little better at this. What do you get? I'm going to say, the 5 cubed is 125 to the 1/6, and then 5 to the 1/6. And what do you over there? Well, you get 5 times 125. Not that I want to do that, by the way, but this is going to be the 1/6 power, isn't it? Let's write this over here. So I'm going to put down Well, you know, maybe I should multiply it. So 125 times 5. You know what? It's got a bunch of 5s in it. Let me just put this over here. 125 times 5. I'm not going to multiply that. That's 1/6. Now, what I want to do is I know there's a bunch of 5s there. So I'll write them down for you. So 125 is actually 5 cubed. Let me just put a line over here indicating that's the old problem. And times 5 is to the 1/6 power. And what do you have there? Well, you get 5 to the... Whoops, I'm sorry. I made a mistake there. I don't know how that happened. I was thinking forward, and that's bad news. That's going to be 5 to the 4 to the 1/6. And now I'm going to multiply the exponents, right? So 4 times 1/6 is 4/6, which is going to be 2/3. 5 squared is 25, so it's the cube root of 25. We got that done. Not bad. All right. Now this one here, it says multiplied, and I'm hoping I can do that. I'll write it down for you. So this is going to be 3, the root of 1 plus x minus 4 root x times, let's take a look at that, the root of 1 plus x plus 2 root x. Let's multiply it. And, you know, certainly someone says, what do you mean you're multiplying? I'm taking this, and I'm distributing across these two terms here. And what would you get? It's pretty simple, actually. You get 3, 1 plus x, plus 6 root x, root 1 plus x. I'll take care of that later. Now I'm going to take this, distribute across these two terms, one at a time. What do you get? Minus 4 root x, 1 plus x, and then you get minus 8x. Let's keep going, and I have to be careful. I'm going to just simplify. 3 plus 3x, we'll look at the key later, and I see minus 8x. What did I do? Let me point out what I did. I just did this, and I did this. Now what I want to do is I want to take these two internal terms, and they're like terms, and bring them together. And what would you get? Plus 2. I'm going to simplify this. They're both the same. And what would you get? Well, it's going to be x plus x squared. What do you get here? 3 minus 5x plus 2 x plus x squared. Let's look at the key. See how we did. I got this. I got this. Yep, got it all. Let's do the next one. This one says introduce the coefficient. I want to remind you what that means. This is the coefficient, and I got to bring it on the inside. So let's do it. How am I going to do that? One step at a time. So I'm going to write this as the cube root of something times the cube root of something. Now, to get it to be the cube root of something, it has to be 2a, right? So that would be 8, because the cube root of 8 is 2. And then the cube root of a cube would be a. I got these two radicals, or cube roots. And what do you get over there? You would get 24. I'm multiplying their radicands. And you would get a cubed x squared. Like I always say, check the key to make sure that you're staring at what they said it is. And if you're not, there's something wrong. All right, this one over here, they want me to divide. I'll write this down for you. They want me to divide the cube root of 405 by the cube root of 5. Let's see if we can do that. I would write it as a cube root of 405 over 5. I'm going to divide through. That's cube root. I want to repeat this. If you have trouble with the arithmetic, write it down. So it's 5 into 405. That would be 8. That would give you 40. You get 5, 81. So I'll write this over here. So that's not so bad. Now, someone's going to have the answer. I'm not saying it's not an answer. I'm just saying it's not the correct answer, but you're getting close to it. So I'm going to write this over here. This is the cube root. Well, there's a perfect cube contained in 81, and that's 27. That's 3 cubed, by the way, and that's times 3. What do you have here? Cube root of 27 is 3. So 3 cube root of 3. All right? Again, just a reminder, these things are typed up. You know, my chicken scratch, it's readable, but I'll be honest with you, it's really the typeset work that we're trying to go towards. And I spend a lot of time typing things up. Main reason being that's what you do when you become a professional. You have to type things up. Let's keep going. Let's do the next one. This one's a little bit stranger because they have different indexes. So they want me to divide, I'll write this over here, they want me to divide the cube root of 4 by the square root of 6. And I got to get them in the same roots, right? So I'll write this over as 4, when I say the index, so 1/3 and 6 to the 1/2. Let's keep going. And again, your mileage may vary. You may say, I'm going to do it differently than you. That's fine. When you get over here, I'm going to say a sixth root. So 6, let's see, I have to do 3/6, right? That's a half. And what's over here? This would be 4 to the 2/6. Mistakes can happen. I'm going to do the whole number, which is 4 squared. That's 16 to the 1/6. And the bottom, oh boy, this is going to be tough. 6 cubed. 6 times 6 is 36. And 36 times 6 is 180 and 36, 216. Again, if you need to do arithmetic on the side, please do so. What are you left off with? And I'll write it down for you. You're left off the 6th root of 16 over 216. Yep, it's frustrating. It's a lot of work. You say, when's it going to end? I don't know. It'll end when it ends. And let's start reducing. And I'm looking at that, and I'm going to say, I'm going to divide. I'm doing this over here, 16 over 216. I'm going to reduce it slowly, too, by the way. 8, dividing by 2, 108. Boy, that divides again, right? So 2 would give you 4, and then you get 50, let's see, 54, right? Boy, it divides by 2 again. What do you get? 2, and 54 would give you, divided by 2 would give you 25, 27, right? So I get 2 over 27, the 6th root of 2 over 27. I got troubles, though. I'll tell you what the troubles are. I can't have that because the radicand's fractional. So what I'm going to do is I'm going to try to multiply it by something that makes it a perfect 6th power. And again, you may look at that and say, I have no idea how to do that. Let's just go through that. This is 2. This is actually 3 cubed. So what do I got to do? I can multiply top and bottom by 3 cubed. And why is that? It would make the bottom a perfect 6th. Oh, I'm sorry. I got that in my mind over here. So what do you get? The 6th root. I'm doing the top number. Well, 2 times 27 is 54, right? What do you get in the bottom? 3 cubed times 3 cubed is 36, and the 6th root of 3 to the 6 is just a 3. Let's check our answer key and see if we got that. I got it. We did okay. All right, this one over here, likewise, same story. It's not really much changing at this point. They want to take the root of 10 and divide it by the 6th root of 40. Now, some students may claim they're going to do it in their head. I do not recommend that. I recommend putting down some work. But again, some people are faster than others. This can be 40 to the 1/6. And what I'm going to do, I'm going to try to get everything in the same index, which would be a 6. And this would be 10. Gee, what would you get there? You get 3/6, right? And over here you get what? 40 to the 1/6. Well, I'm going to write them now. I'm going to use that whole, that 3 and the 10, which would be 1,000. And that's going to be 1/6 now. And what do you get in the bottom? 40 to the 1/6. And what do you get over there? And again, I got to tell you what we get. We're getting the 6th root of 1,000 over 40. All right, I want to just go this side. Let me erase some of my scratchy work on the side over here. And I got some arithmetic for you, all right? And again, some people are faster than others, but it's not a speed contest. That's the same thing as 100 over 4, and 4 goes 125 times. So what do you get over here? The 6th root of 25. All right, I'm looking at that. And I'm saying that's a fine answer, by the way, but I'm saying I do see the answer, but I'm going to say maybe there's something else to do. So let me put this over here. And again, I know it's, some people say, no, I'm at the end. I'm not saying you're not at the end. I'm just saying there's something else to do. And you should notice that about the answer key, by the way. So I'm going to say 25 is actually 5 squared, right? So it's going to be 5 squared to the 1/6 power. What's it going to be? 5 to the 1/3. So it's really the cube root of 5. All right? Pretty easy. All right? So look at that. Look at the key. And if you're not seeing your answer in the key, I mean, this is the final answer, by the way. If you see this thing over here, you say, oh, there must be more work. There must be more work. All right, let's do the next one. Certainly some people look and say there's a lot of busy work. I'm not saying it's not, but I got to get this thing written down. They want me to divide. I'll write this over here for you. That's the 4th root of 6. These are principal roots, by the way. 2 times 3 to the 1/2. And they want me to divide by the 4th root of 3. All right, so what I'm going to do is I'm going to try to get everything in the same base, right? And what I mean, looking at that, I'm going to say 4s. I'll put this over here, and I'll write this over here. So 6 to the 1/4, 3 to the 1/4, it's going to get tough, 2 to the 4/4, times 3 to the 2/4. Again, if you're faster at that, that's fine. I'm not saying you can't be fast at it. 6 to the 1/4, right, minus, well, I'm going to 2 to the 4. That's 2 times 2 is 4, 8, 16 to the 1/4, times, well, I'm going to do 3 squared, which is 9 to the 1/4, over 3 to the 1/4. All right? I'm going to kind of write it down now, and I'm going to kind of split into 2 separate terms, by the way. So I'm seeing 6 to the 1/4, over 3 to the 1/4, I'll do that later, minus 16 to the 1/4 times 9 to the 1/4 over 3 to the 1/4. All right, now I'm certainly looking at, one term at a time. I'm looking at this over here, and that's going to be 6/3, which is 2. That's going to be the 4th root of 2. I'll write that down for you. Minus, well, let's keep going. And what I'm going to do is I'm noticing that these guys really do behave well together. All right, what would you get? You would get 9/3, which is 3 to the 1/4. So I'll write that down for you. So 3 to the 1/4, which would be, I'm sorry, I made a mistake in the copy there. I had 3 in my mind. But it's a 4th root of 3. Again, 9 divided by 3 is 3. We're doing the 4th root. And 16 to 1/4, you might say it was a waste of time doing that, but I know what that is. It's just 2. So I can put a box on this. Yep, mistakes can happen. That's why we give you a key. We want you to self-assess. 4th root of 2. Wow, got it right. Okay? This one says raise this to the 3rd power. I'll put that down for you. So you can get 12 to the 1/6, and they say raise to the 3rd power. And I'll be careful. What do you get? 12. Well, let's see. 3 times 1/6 would be 1/2. So really what is it? It's just a square root of 12. Immediately what do I see? A perfect square is contained in the 12, which is 4. The square root of 4 is 2, and we're left off with a 3. So the root of 3. So 2 root 3s. All right, let's keep going. And I know we're doing a lot of problems here, right? So let's put this one up. 2 to the 1/5. That's what that means, to the 4th power. What do you get? Let's write this down. 2 to the 4/5. Certainly a proper fraction. 2 to the 4th power, 2 times 2 is 4, 8, 16. So it's the 5th root of 16. Yeah, look at the thing. Okay, this one, it says extract the cube root of. Let me write this down for you. I'm not saying it's going to be easy for you. I have to read it first. So I got 27 x cubed to the 1/5, and they are raising that. I'll write this down for you. It's tough. I'm not saying it's going to be easy for you. They're raising it to the 1/3. They said cube root. Now I'm going to write it a little bit differently. I'm going to write it as 27 x cubed to the 1/3 raised to the 1/5. And again, you should know multiplications are commutative. That 1/5 times 1/3 or 1/3 times 1/5, same thing. Now I can take the cube root of 27. What's that going to be? 3. And the cube root of x is just x to the 1/5 power. I'm going to write it as a radical because it's written as a radical to start with. And what's that going to be? The 5th root of 3x. I see that right over there. Let's do this one over here. And again, we're getting towards that point in the problem set where we're probably going to have to take a break. But let's write this one down. This is going to be 6 to the 1/3. And what they want to do, extract the 5th root. And again, these are principal roots. So looking at it, not much I can do about that, is it? So I'm going to say 6 to the 1/15. And 6 just has a factor of 2 and 3 in it. So it's just going to be the 15th root of 6. All right? All right, this one it's nested. No one likes a nested root, by the way. Let's write this down. So it's going to be 4 times 2 to the 1/2 to the 1/5. I'm going to simplify what's on the inside now. And the way I'm going to do that is, I'm noticing it's powers of 2's, right? So it's going to be 2 squared, 2 to the 1/2. It's going to be 1/5. I'm still working on the inside. What do you get over there? Well, you get 2 to the 5/2, right? To the 1/5. What does this give you? It's really kind of simple, because 5/2 times 1/5 is going to be half. So you get 2 to the 1/2 power. What's that going to be? The root of 2. So this turns out just to be the root of 2. Let me go back over here. I make mistakes sometimes, and want to encourage you, please, if you make a mistake, try to rectify it. All right, let's do this one over here. This is 24. It's root 6 minus root 3, and we have to square it. I'll write that down for you. Again, some students argue that they can do this without writing it down. I'm not saying you can't do it without writing it down. I'm just saying I want to write it down to students that need it written down. Root 6 times root 6 is 6. Then you're going to get, root 6 times root 3 is minus root 18. We'll take care of that later, by the way. Then you get minus root 18. And then what do you get? Minus and minus is plus 3. Well, let's write this down. 6 plus 3 is 9, minus 2 root 18. What do I notice immediately? Root 18 contains a perfect square, which is 9. The square root of 9 is 3. And what do you get over there? Root 2. What do you get? 9 minus 6 root 2. Looking good. All right, this one, more complicated, but let's write it down. It's a pattern to it, though. What do you get? 4 times 4 is 16. Minus, let's be careful, 4 sixth root of 5. Then what do you get? Plus 4 sixth root of 5. Then what do you get? Minus the sixth root of 25. All right, these are easy. I'll tell you why. Something's happening. This is a very simple pattern. The pattern's being listed over here for you. But I got troubles now. My troubles are, if you put this down as an answer, not that I'd say it's wrong. It's really not wrong. It's just not as simple as it should be. And I'll tell you why. The sixth root of 25 is the same thing as 5 squared to the 1/6, which is 5 to the 1/3. So it's going to be 16 minus the cube root of 5. All right, this one says factor. Factoring, for some students, you say, what do you mean you can factor that guy? Well, one thing I do know, a 2 comes out. That's called the GCF. And what I'm going to do is I'm also going to factor out the root of x. And what do you get? You would get 1 minus 3 root x. That's a factorization of the problem, by the way. We're done. All right. This one says factor using square roots or surds. And again, I know it's difficult, but the bottom line is this also can be factored. How's it going to be factored? Well, let's write this down. Root A, we're using a surd or a root problem. Root A times root A is A. That worked out beautifully. And then this difference of perfect squares, but these are really square roots. And that gives me the proper thing. That's written over here. All right, more difficult. And when someone says, what do you mean it's more difficult? I'm kind of looking at it, and I want to remind you of a pattern. And the pattern I want to remind you of is a cubed minus b cubed would be equal to a minus b. And then when you get over here, well, let's write this down. You get a squared plus ab plus b squared. So, and again, some people look and say, I don't think I could do that. I think you can. All right, so I'm going to write this down. And let me write this down over here as a to the 1/3 cubed minus b to the 1/3 cubed. All right, that's the same thing as this thing over here, by the way. Let's write this down. What are you going to get? Well, you're going to get a to the 1/3 minus b to the 1/3. I'll have to clean this up later, by the way. A squared would be a to the 2/3 plus a times b is a to the 1/3 times b to the 1/3 plus b squared would be b to the 2/3. I'm going to clean this up. This would be the cube root of a minus the cube root of b. Then you're going to get the cube root of a squared plus the cube root of ab. Look at the key later. Plus the cube root of b squared. All right? Let me look at, I think I just touched something. And let me see what happened there. What number were we on? I think I might have hit an undo button or something. I'm sorry about that. Yeah, so I'm going to say we'll stop here. We just did this. We actually got that answer. And I hit the undo button or something. That's why things disappeared. But anyway, we're good to here. So we did this. We're going to break this into two parts. I'll just come back and finish this a little bit later, okay?